Hi folks, this is the final lecture of week 6, lecture 2, and it's the last lecture on finite element subject. And remember, you're going to be writing a midterm tomorrow. After the midterm, when you return from the summer break, we are going to abandon the finite element analysis and move on to something which is entirely different. Okay, it is a relatively short presentation because I just want to show you some of the items that were reported to me by a couple of students, and there are error messages that they were getting, and they were not quite sure why that was the case. Okay, so here's the situation. This is the item that we're going to cover on the agenda today, and it's about these two messages basically, non-connects and non-manifold type messages. Katia will complain that you are dealing with this situation. And I just want to remind you that the version of CATIA that I have on my laptop, and I'm using it right now, it's an older version, which is different from what you have at the university. And although there may be a few items in the dialog boxes that you do not see it at your establishment, but you'll get the idea. So here is the two messages that I'm referring to. You may get an error message like that when you're trying to do finite elements on shells and the beams. You may get this message or maybe both of these. Okay, and I'm trying to show you in the context of an example what you need to do. Here's a situation that I'm going to model for you in a minute. First of all, I have two surfaces like that. I create two surfaces like that. Notice that they're not attached to each other. They're not next to each other. And when you try to join it, you get a message called non-connects. Now, this is the dialog box that I get in my release of the CATIA. The one at the university is more recent and it looks like that. In fact, look, even the spelling is different. It says check connectivity. And for about, I don't know, 20 years, I was wondering, what is the word connexity? So it's really connectivity, but anyway, there it is. And also there's a checkbox here, which I don't have it in mine. It says something dealing with the heal icon in generative shape design, which I don't have it. But anyway, when I show you this, you'll get the picture why that's happening. Now, to fix this, all you need to do is to remove that check connexity or check connectivity. Okay, so when you do that, when you uncheck this, when you uncheck that, everything is going to go through. See, uncheck it, you'll join it together, no messages. And the problem that I'm going to do for you, just to show you that this is going to happen, is basically you have these two plates, these ends are clamped, this and that, and I want to do this top face is subject to some pressure, and this is some pressure in a different direction, and I want to solve that problem. So in trying to do this problem is that I'm going to come across these messages in case I try to join them. The dimensions are not important, so let me go ahead and do this, and I'm going to do it as a single part. So here's the part. Since we're dealing with shells, it is a generative shape design, so that's okay. I'm in the right spot. So on that plane, I will sketch. Why don't I make a rectangle here? Something like that. Okay. Exit, and then fill it. F-I-L-L. You may decide to generate the surface a different way. That's entirely up to you. Then I'm going to make another surface up here. But to do that, I will actually create a plane which is offset from that. And I'm going to move it up a little bit right there. I'm going to create that other rectangle in here. Once again, a rectangle. Of course, I can also project these things, but let me do the following. This point, control that point. If you want them to be the same size. There we are. Exit, and again fill it. Fill. There. Okay. Now We're going to apply material to this, although you can do it now or you can do it later. It doesn't matter. But here's the situation. I want to join these two. Okay, these are the two surfaces that I showed you that are not touching. So I'm going to join, try to join. When I select this and that, okay, and when I say preview, I get that connexity message right there. We say it might take some display, so don't connect them. Okay, good. Uncheck this box. See this box here, right there. Uncheck that, and now preview. No problem. It just joins them together right there. You can see that. Let's apply material to this thing just show that we can finish it. So apply material. Let's make everything out of steel, aluminum. It really doesn't matter. I just want to show you the process. And now we're going to go to analysis and simulation, generative structure analysis. We have to mesh these ourselves because we joined them. Actually, we don't have to do them separately. Once we try to mesh it with the mesh one of the plates, since these are joined, they're all both going to happen. Okay, and apply thickness once again. Since they were joined, I apply thickness is going to be applied to both. These are all dummy numbers. Okay, and now we're going to let me hide these sketches. There are two sketches here, one here, one there. Okay, so I think I said that I'm going to clamp that side, and I'm going to clamp, or for some reason, this side. I'm going to apply a pressure like that. Notice that it is downward pressure. You can see actually, yeah, it really doesn't matter. If you want it downward, I put a minus here. Right there, you can see that it's downward pressure. Okay, and I'm going to apply same value, except that if I want it to be into the object, I put a plus sign. As long as you fool around with the signs so that they come out to be right, they'll work out. That's pretty much it. So we're going to run it. Done. And if you look at, for example, deflection, change the rendering. Now, you might say, well, wait a minute, how come this didn't deflect? It actually deflected, but this is because of the nature of the restraint here. This is very stiff. Okay. For example, if I want to see the deflection of that, all I have to do is to double click here on the selection. Just say, show me. Because I have to. Okay, because I joined it. I cannot show you the elements down here, but let's do it a different way. Let's do it a different way. I want to convince you that actually there is colors here. Obviously, if you put the numbers on it, you can see that the numbers are changing. But let me show you a different way. So I'm going to say deactivate this. Deactivate. I'm going to create a surface group. Here's the group. Surface group is, I believe it's this one. Surface group. Just show me, create a surface group for that. And now when I activate that plot and I double click on it and I select the surface group, it shows you that it's actually bending. Good. So that takes care of this problem. So let me get rid of that and get rid of this. Another simple problem, let's take, I'm going to do two problems for you. One of them is like that. So we have basically three bars in space. The ends are clamped and they're joined at one point. Joined meaning that they're welded at one point, and then you apply force here. Okay, so what I want to do is create these lines, and I'm going to join them. But when I try to join them, and you might say, do you have to join? Well, if you don't join, that's okay. But remember, there will be multiple, when you mesh these three lines, there will be multiple nodes at this corner point, and you have to fix that. It is possible to fix it. But if you join them and then mesh it, then there will be a single node at that point, and there is no requirement to put these three beams together. Now, that's the motivation behind me joining these three lines. Now, notice that when you do that, you get two references to something called non-manifold and non-connects. This non-manifold only comes up, or at least in my experience, when you're dealing with lines. So so when you do that, when you go here and you notice that when you try to join these things, these boxes are automatically checked. So all you have to do is to uncheck the non-manifold. You uncheck the non-manifold, uncheck this, and everything will go through. Okay, I'll show you in just a minute and finish the problem. Okay, and remember, when I uncheck that, then automatically this guy goes away and we can solve the problem. And then I'm going to come back and do this problem. Same issue applies to this. Okay, so let's go out here. The actual location, size of the beam, number, cross section, these are not important. So what I'm going to do is I'm going to create 4 points in space. This is where the load is going to get applied. Another one, the end of that bar. So let's see now. Let me go, for example, up a little bit to the right. Okay, that's one of them. Another one. I'm going to go a little bit more to the right and maybe down a little bit. Okay. And another one further down. Okay, a little bit to the left. Okay, good. And now create lines here. A line from here to here. Another line from here to here. And another one from here to here. So basically what I'm doing here for you is this configuration, like something like that. All right. Now, let's try to join these things. Okay, when you try to join, you go on the join operation and you select these 3 lines. And then notice that these 2 are both checked. And then when I say preview, I got the message non-manifold, non-connects. So what I'm going to do is I'm going to uncheck this guy. When you uncheck this, this goes away automatically. And now when I preview it, it's all joined. Okay? Let's do the rest of the problem. First of all, let me get rid of all these or hide all these nodes. Just remind you how you can easily hide stuff. So you go to Tools, Hide. While you are in the generative shape design or generative or part design, so hide all the points. Okay, so it's all gone. It's good. Good. Let's apply material to this thing. To solve the problem, you need to have a material, say aluminum. Okay. And then we're going to go to generative structure analysis. Because we joined it, we don't have to do it 3 times. We're going to mesh with beam element, that entire join. That was one reason that I actually joined them. Otherwise, you have to join these things separate. Also, you have to mesh these things separately. There will duplicate nodes here. You have to fix it. It can be fixed, just that's hassle. All right, so that and the cross section, because it's joined, everything is going to be the same. It's cylindrical and some radius, whatever the radius is. That's beside the point. Okay, so let's clamp this and that and that. Okay, and let's apply a force to that vertex. Okay, so it's whatever it is, minus 1,000 pounds. But these are just dummy numbers for sake of argument. You can see that. And now pretty much done. We're going to run it. Nothing exciting is going to happen. This is going to bend. And you can see a deflection right there. Change it to average ISO. There we are. And if you want, you can animate it. Okay, so I hope that you get the picture. When you get these messages, you have to go and basically fool around with the check connectivity, or in the current version that you have installed, at school, check connectivity, and check manifold. Okay, just try to adjust these so that you can actually join the two structures. All right, good luck.